In this video, we will be going over the following topics for ellipses: major axis, minor axis, vertices, and co-vertices. So the major axis is the longer axis on the ellipse, and the minor axis is the shorter axis. The vertices are the endpoints on the major axis, and this is plural for vertex. The co-vertices are the endpoints on the minor axis, and this is plural for co-vertex. Remember that for a circle, the equation is x minus h squared plus y minus k squared equals r squared, and this is where hk is the center, and r is the radius. So in a circle, we have the center right in the middle, and then the radius is the same length from the center to any endpoint across. So this would be the radius as well. The diameter is then just the length from one endpoint to the other that goes through the center. So each of these lines in yellow would be the diameter. And as we can see here for a circle, the diameter is the same length no matter where we draw it. As long as it goes through the center and the endpoints, the diameter is always the same length. Well, now let's look at the equation of an ellipse. So it looks very similar to the one of a circle because we still have the x minus h squared and the y minus k squared part, which will also be the center. But now instead of being equal to the radius squared, we're equal to 1, and then we have numbers under each of these x terms and y terms. So an ellipse is essentially just a circle that has been stretched horizontally or vertically. So if it is stretched horizontally, that will give us a horizontal ellipse. So instead of having a diameter, it's going to have a major axis and a minor axis. And the major axis will be the longer axis, and then the minor axis will be the shorter axis. The vertices will be the endpoints that are on the major axis, so this will be one vertex, and this will be another vertex. And then the co-vertices will be the endpoints that are on the minor axis. A vertical ellipse is an ellipse that has been stretched vertically. So in this case, the major axis will be the vertical axis, and then the minor axis, or the shorter axis, will be the horizontal axis. Once again, we will have each vertex on the major axis, and then each co-vertex will be the endpoints on the minor axis. And for both of these, the center will be right in the middle. Now let's look at an example. So given the ellipse x minus 2 squared over 16 plus y minus 1 squared over 49 equals 1, find the following: the center, the length of the major axis, the length of the minor axis, vertices, and co-vertices. First, we want to see whether this is a horizontal ellipse or a vertical ellipse. Well, this is going to be a vertical ellipse because the number under y is greater than the number under x. So this will give us a vertical ellipse. And the center will be 2, 1, because we will just do the opposite sign of what's inside of the parentheses there. So I will draw my center. And then b squared will be 49. So if I take the square root to each side, then I get that b is 7. So this is going to be the value that I move up and down from the center. So if I first go up 7, then I will just need to add 7 to the y value of the center. So 1 plus 7 will give me 8. So that top vertex will be 2, 8. And then if I were to go down 7 units, I would just have to subtract 7 from my center. So this other vertex would be 2, -6. Then we can see that our major axis is this entire length. So if half of the distance is 7, then the entire length would be 7 plus 7, which is 14. And then a squared is equal to 16. So if I take the square root to each side, a equals 4. And this is the value that I will move left or right from the center. So if I move to the right 4, I will just be adding 4 to the x value of my center, which will give me 6. So that co-vertex will be 6, 1. And then if I move 4 to the left, then I would just be subtracting 4 from the center. So 2 minus 4 will give me -2. So my other co-vertex will be -2, 1. So as we can see, my minor axis will be the length from -2, 1 to 6, 1. So if half of the length is 4 and the other half of the length is 4, then if we were to add those together, we would get 8. So the length of our minor axis will be 8. And then I can just fill in the rest. So our vertices would be 2, 8 and 2, -6. And my co-vertices would be -2, 1 and 6, 1. And that is how we can find the length of the major axis and minor axis, and how we can find the vertices and co-vertices as well.